All right, good afternoon. Hope everyone had another great lunch. So thank you, VeriSign, once again for all the great food we've had today and yesterday. So this is FreeBSD at work, building network and storage infrastructure with pfSense and FreeNAS. This talk is going to be about these two appliances, their place in the ecosystem, their effects on the community, and why they're important. A quick little disclaimer for the copyright enthusiasts among us. All right, so my name is Conor Beh. This is my first VBSD con. I've been to a couple of Linux fests, been to OzCon. I was at MeetBSD last year and had a lot of fun. So this is my first time presenting at a BSD conference. So I got into sort of technology and IT in like high school. I went to a very small school, which was plagued with, well, all the generic Windows issues you can think of, and got started helping out with that. I was looking for a podcast at the time, and I heard about something called TechSnap. You may have heard of it, which just started at the time. It was a few episodes in, and I tuned in, really enjoyed myself. The two hosts were talking about, of course, BSD, FreeNAS, and pfSense, which I got introduced to. And I decided to try it out at home and sort of fell in love with open source as a whole, and I ventured into FreeBSD and schmids of OpenBSD, so I need to get into that a bit more. Okay, so let's start off with a little bit of history. This is monowall, so both FreeBSD, both pfSense and FreeNAS are both based on monowall. Monowall was released in 2002. It spawned not just pfSense, FreeNAS, but a couple other projects as well. So in 2009, the FreeNAS team decided they wanted to do some sort of rewrite because they wanted some plugins and some other features. And the idea of Linux was thrown around a bit, but they ended up transferring development over to IX Systems, where they sort of have been developing it ever since, and it's turned into something great, and it's continued to be great. So pfSense was also started from monowall in 2004, and its first release was in 2006. And it's continued under NetGate. There's another project called OpenSense, which is a fairly popular routing and firewalling platform forked from pfSense, which was in 2015. Okay, so let's talk about pfSense. So the world's most trusted open source firewall. This is in quotes. I don't say this. NetGate, the developers, say this. I'd say it holds fairly true, just because there's a fair amount of people who trust their traffic to this machine. And it's not only in a lot of home environments, but in a lot of business and enterprise environments as well. That's what is pfSense. So it's a firewalling and routing platform. So you got your typical firewalling and routing features. It can also do various network services. Network services is sort of an umbrella term I'm going to use a fair bit in this presentation. What I mean by that is I mean DHCP, DNS, maybe DNS level ad blocking, radius, capture portaling, whatever you may be that you want to enhance your network with. Okay, so use cases. So there are a lot of firewalling and routing vendors. I mean Juniper, Cisco, Fortinet, Ubiquiti, just to name a few. There's even more single service-based appliances that are just an intrusion detection system, or maybe you're running some of your other services on a different device. DHCP is very, very commonly put on your Active Directory domain controller. But at the end of the day, pfSense is FreeBSD, and you get all the great things that come along with that. It's free and open source, and that's really important to a lot of people in this room. We're all here because we love open source. So it's got the PF packet filter, which we'll talk about in just a moment, and it's got all the other stuff right in the nice little package. You can all manage it from the web UI. All right, so let's talk about the PF packet filter. So this came to us from the great folks over at OpenBSD, and it was released on December 1st, 2001. It's since been ported to not only FreeBSD, NetBSD, DragonflyBSD, Solaris, and there's probably a few others. I think it's even on iOS at this point. Correct me if I'm wrong on that one. So one thing I will note here is that the PF on FreeBSD and OpenBSD have diverged a little bit. They're not nearly the same. There is some work, I believe, going on to try to get them back fairly on peer. So PF is a stateful packet filter. So what's the difference between a stateful and stateless packet filtering system? So a stateless packet filter determines whether to block or pass traffic, typically based on the destination address and the source address, and which is, of course, stored in the header of each packet. So a stateful firewall determines whether to block or pass traffic by further examining the connection itself. So it tracks the state of the connection coming across the firewall, puts that in a state table, which we'll talk about in a moment, and it monitors that state. And it's significantly more advanced as it's based on context, and it's aware of the connection from end to end. So the state table. So when a state comes across, it's recorded in the state table, and only traffic that matches the state in this table are allowed to pass. And it records a fair amount of information in there, ports, IP, source and destination, protocol, things like that. So states are removed typically in one of two cases. So one, traffic's timed out, such as the case with UDP, or if there's a mechanism to terminate the connection gracefully, such as with a TCP connection in the use of the FIN-ACK. So the biggest impact to performance happens at the beginning of the connection when it's first recorded to the state table. And of course, when you're using a non-bidirectional connection like UDP, you do have to wait for that connection to time out. So since only connections matching a state currently in the firewall are allowed to pass, it only opens a port when that is the case, so you can't just sit there and do port scanning and find all the open ports. So what a stateful packet firewall allows you to do is it allows you to further differentiate traffic by protocol in this case. So you're not just indiscriminately nuking certain traffic that you may care about. You can also use something like Snort or Suricata, which we will talk about later, to act as an intrusion detection or prevention system. And UDP hole punching. So UDP hole punching is something I put in here because I think it's really cool. So the way UDP hole punching works is it's a method of NAT transgression, and so, or sorry, transversal. And what that is it takes two hosts who are currently connected to some server in the middle, and it uses that to transverse the firewall. So some may consider that a security risk, and in some cases you'd be correct, but it also has very legitimate uses, such as the case with peer-to-peer file sharing. So the state table, I apologize, this is a little bit hard to see. I just took a screenshot of this on a rainy Sunday afternoon sometime. So let's go over it real quick. So columns left to right, so we've got the interface, protocol, IP source and destination, the current state, the number of packets and the bytes received and sent. So over the top few rows here, we've got a time wait. And so what a time wait is some sort of traffic has either arrived late or it's arriving out of order, and so we're waiting for that to complete. Further down, we've got a send close, so that's closed gracefully this time, thankfully. Then we've got some UDP traffic that there's no more, so it's going to be axed here pretty shortly. And then down towards the bottom, we've got a fin wait 2. So remember with TCP, when it closes a connection, it does so with a 4-way handshake, and the fin wait 2 is simply the second step of that handshake. All right, so interfaces on pfSense. So not only do we have your typical WAN and LAN interface, maybe it's just a simple Cat5 to your modem or whatever your upstream is, and that's your WAN interface. You've got a LAN interface going to a switch or something, and you can absolutely do that. But you can also do things like assign bridges to a WAN or LAN interface, which is something I've done at home. So what I've done is I've taken 3 interfaces. One is for my VMs, which is a virtual interface. One is a physical port that goes to an access point, and another one goes to a switch, and I put those on a bridge and assign that bridge to the LAN interface. It just makes it much more simpler. That way I don't have to manage rules on all 3 interfaces separately. So tunneling interfaces. So when we create something like a VPN server or client, we can create a separate interface for that so we can manage that separately. Generic routing encapsulation interfaces. Most notably, Cloudflare would use something like this. What they do is they take all your traffic into their system, scrub out the bad stuff, and they have a GRA tunnel that just sends all the hopefully good traffic over to your web server or whatever you're putting behind Cloudflare. Some other more exotic stuff, generic tunneling interfaces, IEEE 802.1q inside 802.1q, wireless interfaces. So when you're doing wireless natively in pfSense, that's not the best idea. There are some problems with that, so you're much better off just taking a local just putting that on your LAN and maybe plugging in your access point to a switch or something. All right, so gateways. So interfaces are not magic. You still have to have gateways to get somewhere. So gateways are a method of allowing traffic to access outside networks. So up here, I just got a little picture. This is a PPPoE gateway, just on a DSL connection at home. So we've got the PPPoE upstream server, the round trip time latency, the packet loss, and the status. So gateways are derived from the interface type. So if you have a static IP or a dynamic IP, that's going to depend on whether whatever your gateway supports that. VPN gateways. So traffic over VPN still needs a way to access the internet or get to wherever your upstream VPN server is. Authentication. So some gateways do provide for authentication methods, such as the case with PPPoE. It's a simple username and password, used very commonly in small ISP setups or even big ones. Monitoring. So pfSense does monitor for both latency and packet loss, and you can configure the interval at which that happens and what server it's monitoring. So by default, I believe it picks whatever your PPPoE server would pick that to monitor. But you can also change that to monitor maybe just 8.8.8 or something if you want to do that. And you can configure alerts based on certain thresholds or trigger failover. Say you've got two WANs, maybe one's your gigabit fiber connection and the other one's your little 50 meg DSL connection. You can fail over if packet loss reaches, say, 30% or something. All right, so traffic shaping. Traffic shaping is an often misunderstood, infinitely complex topic. And I will say, if you don't have to traffic shape, don't. It's not a magical thing. So if you can increase your network throughput in other ways, maybe it's as simple as upgrading your internet connection, do so first. So on pfSense, traffic shaping is accomplished in one of two ways, queuing and limiting. Queuing is the most intelligent, and its queuing method is dependent on the type. So we've got prioritization or deprioritization, bandwidth allocation. This is typically a percentage, or fair queuing, which we'll talk about in a moment. Limiters, you just use firewall rules to put certain types of traffic into a size of pipe. Maybe you want to limit a connection to a certain throughput. So pitfalls and limitations. There is a bit of increased resource usage when you're doing traffic shaping. It's not huge, but it is there. So it's only applicable on outbound interfaces. With this, you cannot really control the traffic coming into you. There are methods for that. That's not really under the purview of this, though. So this may also cause issues with replication or failover, which we will talk about, mostly because there is a lot of moving parts to this. And also, some UPnP connections are not compatible with some queue types. UPnP is essentially just allowing you to open a port automatically instead of doing the manual port forwarding stuff, used for a lot of hosting services. All right, so let's talk about a couple of the most popular queues. So we'll start with HFSC. So this is the hierarchical fair service curve. So this uses only bandwidth. So traffic is put into a queue for each interface. This is one of the reasons I put all three of my LAN interfaces into just one bridge and then assign that to the LAN. So it is fairly complex to set up. So class-based queuing integrates both priority and bandwidth levels. It also uses a hierarchical tree, but unlike HFSC, it processes packets only until the desired bandwidth limit is reached and then stops. PriQueue, this is pretty simple. It's based on priority only. You assign a number. I believe it's 1 through 15. And you use, once again, use firewalls to drop traffic into each queue. All right, FQCoddle. So FQCoddle is something that's quite popular and has gotten so in the last year or so. It was on pfSense for a while, but it only recently hit the GUI. So FQCoddle is called Fair Queue Control Delay. And the reason I put this picture of the Holy Grail up there is because that's what people think it is. It's a checkbox and all your headaches go away. That's not really the case. So FreeQCoddle was designed to combat buffer bloat. Buffer bloat is simply the cause of high latency in packet switch networks caused by an excess buffering of packets. So if you're trying to, max out your upload speed, you're not going to get much download. So it's built as a no-knob solution. Just hit the checkbox and you're off to the races. That's not true. One of the huge things that FQCoddle depends upon is an accurate representation of your interface speed. And that's not the line speed. That's, say you've got a gigabit interface. It's not the gigabit speed. It's whatever your actual WAN speed is if you're doing it on that side. So say you've got a 100 megabit internet connection. Well, it's probably not going to be 100 megabit 100% of the time. So run some speed tests. Don't just run 1. Run 10. Take the average. Use that. It's going to solve a lot of headaches later on. So unlike first come, first served queues, which we just talked about, FQCoddle is intelligent. That means it's much more accurate, and its queues are kept mini and kept short to equalize all the connections, because that's what it's trying to do. It's trying to make sure no one bandwidth hog can really destroy the day. All right, network services. This is the term I mentioned earlier. I use it for a lot of things. So DHCP, you can also forward to an upstream server. Like I said, very common to have DHCP co-located with your Active Directory domain controller. DNS, both authoritative and recursive. DNS forwarding. If you've got a DNS server elsewhere, PPBoE server, if you want to start your own ISP, absolutely can do that. Dynamic DNS, so dynamic DNS works essentially by using an upstream provider where whenever your WAN IP address changes, it will go, okay, hey, my new IP address is this, please update the DNS record, and there you go. So captive portal, so I'm sure a lot of you experienced the captive portal here at the hotel. You tried to hop on the Wi-Fi and you got to type in your username or your email address and type in a password of some sort. Well, you can absolutely do that. You can authenticate via local users and groups or Radius. If you want to use Radius, maybe host it on the pfSense or somewhere else. VPN clients and servers, OpenVPN, IPsec, OTTP, you can absolutely do that. IPsec and OpenVPN are really the two most popular options, and they are for a reason. Intrusion detection and prevention. So this is not built into pfSense natively. It's provided by 2 third-party packages. Snort and Suricata are roughly on par in terms of their performance and features. However, Suricata is multi-threaded, so if you are going to be doing, putting quite a lot of throughput through, you definitely want to look at Suricata because the multi-threaded is definitely going to save you there. So these use real-time packet analysis to detect attacks using a variety of criteria. And those methods of detection can be classified in 2 ways, typically. So signature-based, this is dictated by rule sets. So rule sets are something you can find online. There are a few that come stock. You can buy some. There are paid subscription-based ones that are updated very often. Some community members have also compiled some really great free ones as well. Just shop around for what you need. And anomaly-based, this is just looking for anomalous traffic, and it'll take action on that if you want to. So the difference between a detection and prevention system is really a detection system will alert you, log, whatever it may be, and a prevention system will actually put in prevention measures to stop that, whether it be a firewall rule or just drop the traffic or something. So definitely one thing I want to mention here is DNS level ad blocking called PFBlocker. So this is, again, a third-party package. You just hop into the package manager in the web GUI, click install. It's got its own web page and everything, super easy to configure. It's very similar to Pi-hole if you've ever used Pi-hole. So what this does is essentially black holes certain IP addresses or domain names, both for getting rid of ads. And since it's happening at the DNS level, you're never actually loading the ad itself on your web page, so that can save you a few milliseconds of latency or some bandwidth if you're worried about that. It can also be used to block evil domains and IPs, so malware control servers, stuff like that. And once again, all these things have to be known, so you've got to get your rule sets. There's, like I said, there's a lot of very good free ones, but you can also find some more paid, quickly updated ones. All right, so monitoring. So monitoring pfSense is from the nice little web UI here, just a little screenshot. So you can monitor both traffic and bandwidth on each interface or as a whole. One really nice thing is you can do packet captures right from the web UI, save it as a PCAP file, open it in Wireshark, no more mirroring the port on your switch and plugging into your laptop. Obviously, service status and various information about the hardware, CPU usage, RAM usage, things like that. You can also use other monitoring tools. So there's a Zabbix agent you can install, Nagios, Grafana. Grafana is a very nice dashboard creation tool you can feed metrics into from a variety of sources. You can absolutely install an agent for that. Various other diagnostic tools, iPerf, PFTop, everyone loves Top. Well, it's Top for PF. Ping and traceroute, of course, port scanning tools, and package. And so if you want more stuff, go into the package manager. There's probably some more diagnostic tools in there that might interest you. All right, redundancy and failover. So in pfSense, redundancy and failover is handled by 3 sort of main items here. So pfSync, this is what actually keeps your firewall rules, your states table, your additional configuration concurrent between both firewalls, or more than two if you want to do that. So one thing that you will run into issues with this if your physical interface names are different. Say you're running one pfSense in a VM, one is on bare metal using an Intel NIC or something. If the names are not the same, you might have problems there. CARP. So CARP is another great piece of kit that came from the OpenBSD folks as well. And this allows multiple hosts on the LAN to share the same IP address. So when one host goes down, all your traffic instantly goes to the other one. You're good to go there. And as long as you're working with pfSync, all your states, all your firewall rules, all your configuration, it's all on the same page. So load balancing. So you can load balance between WAN interfaces, both for throughput and for redundancy. Like I said, you can fail over if one dies or reaches a certain threshold of packet loss. You can also use RelayD right from your edge firewall. So normally with a load balancer, you might have to install it on a separate piece of kit and direct traffic that way. So if you've got a lot of servers on the network or something, you can load balance there. All right, OpenVPN. OpenVPN is awesome. A lot of commercial open VPN providers, Private Internet Access, NordVPN, Empire VPN, they all use OpenVPN, even if it's a nice little GUI on top of it. So in pfSense, you can set it up as both as a client and a server. So when you configure pfSense as a client, instead of installing the OpenVPN client on each individual computer in your network that you want to go through the VPN, you can install it on the firewall, connect through that way, and use firewall rules to dictate which hosts on your network go to the VPN or which don't. And then you can also use firewall rules to say, OK, you're going to the VPN gateway, but if you try to go to the normal unencrypted gateway, block, no, that's not allowed. So you can also configure it as a server on pfSense. And there's a very handy package you can install, a client export package. What that does is you simply go to your server tab, click export, and it'll give you an executable with the config file already loaded, and you can drop that to whoever you want to connect. Easy peasy, no more filling in config files, no more typing in all username and passwords. And you can back that both by local users and groups or by radius. All right, so let's talk about FreeNAS. So FreeNAS is the world's most popular open source storage system. There are a lot of NAS software out there, everything from the expensive Synologies and QNAPs to the big boys like NetApp that you pay a fortune and a half for, or Isilon, stuff like that. So since FreeNAS is open source, it is FreeBSD. You get all the great things that come along with that. I believe it has something like over 10 million downloads now. All right, so it's a network-attached storage system. It's got all the file sharing protocols you can manage right from the UI, ISCA, ZNFS, SMB, AFS, FTP, whatever else you want to install in a jail if you want to share that way. It's highly reliant, and that's simply because of OpenZFS. You've got comprehensive monitoring both from the UI and through off-board platforms like Nagios or Grafana or something. And my favorite feature of FreeNAS, and I believe this is shared by a lot of people, is simply jails. With a lot of commercial NAS storage systems, you're kind of stuck with whatever they decide they'll let you run. Now, there are plugins that are available by default. It's a little click play, and we'll talk about that later. Or you can boot up a normal jail, install whatever you want, just package install, grab the binary, whatever you want to do. And you've also got Beehive's full-blown hypervisor, install Windows, install FreeBSD, install OpenBSD, do whatever you need to do there. All right, so ZFS, I'm sure we all have heard about ZFS by now, but here's a quick little history. So the Z file system, originally the Z stood for zettabyte. It's not really a thing anymore. It depends on who you ask. So it started at Sun Microsystems in 2001. And in 2010, OpenSolaris went away, and so it's no longer open source. In 2012, ZFS started to use feature flags. They set the version to something, I can't remember what it was, and said, OK, instead of using incremental version numbers that might interfere with something else, let's use feature flags that dictate what features that each pool supports. So in 2013, OpenZFS is officially announced and unifies the projects. So there's ZFS and Linux. There's FreeBSD. Michael Dexter, of course, gave a great talk earlier about all the platforms ZFS is now available on. And in 2019, early 2019, FreeBSD announced they were going to try to use the ZFS and Linux, which is now the OpenZFS repo, from upstream instead of from Illumos. And ZFS it's on a lot of things now, like Michael Dexter talked about. It's getting everywhere, and it should be because it's a great file system. All right, so we'll talk about the features here just real quick. So it's copy on write. You've got checksumming. Whenever the data is written to the disk, creates a checksum. When it's read back, it compares the checksum, and it's different. If you've got some sort of parity level, maybe mirror, RAID Z, it'll try to prepare that for you. If it doesn't, it'll at least try to alert you. So a scrub simply goes through and compares all that data to make sure there's no bit rot or some other thing went wrong. Snapshots are instant. Boot environment, so in FreeNAS, whenever you do an update, it'll create a boot environment automatically for you so that if stuff goes wrong, you're good to go. So transparent compression, like Alan talked about earlier, it's awesome. It's completely transparent, and you're going to get a lot of space savings with almost no or less speed as long as your CPU is decent, obviously. So if you're trying to run like some Pentium 3 from wherever, then yeah, maybe that's the best idea. But LZ4 is really great on any modern CPU. So read and write caching, ARC, adaptive replacement cache, to reduce latency and increase performance, or the ZIL, ZFS netlog, hold synchronous writes. You can set up a separate ZIL called a slog, separate log device, if you're doing a lot of synchronous writes, say with a VM storage system like ESXi. And ZFS is both a file system and a volume manager. All right, so data sharing. So data sets are individual file systems within a ZFS pool, and you can attach various file sharing methods to the same data set. So say NFS on one, SMB in one, and you can use them concurrently, although if you do, you might end up with resource deadlocks, so be careful about that. One thing that's really nice about data sets is since they're completely independent file systems, you can mess with permissions. So set Unix permissions on one, set Windows on one, and so if they're for different operating systems, you're completely good there. So services running in jails, you can pass a data set directly into a jail, and the jail is going to have complete control of it, can do whatever it needs to do. Maybe you've got one data set that has all your Plex media. Well, you can feed that into Plex. That can do whatever it needs to do. Feed that into your torrent client, download directly into it, do whatever. So authentication for various sharing methods can be based both on local users and groups or something like LDAP, AD, Radius, whatever it may be. So integration, so FreeNAS does integrate with quite a few cloud storage systems. There are quite a few out there, so from Amazon's offering, Google's, Azure, Dropbox, simple stuff, set up your own with like MinIO or rclone. One thing I will mention here is, so if anyone's using Google Drive, there's something called G Suite, which is, I believe it's $12 a month. They say 1 terabyte per user. They don't enforce that. I've got like 9 or 10 terabytes on there, and they haven't kicked me off yet. And what you can do is you can use rclone and FuseFS to take that remote, Google Drive, cache it, and you can mount that direct in just whatever directory you wish, and it can be accessed just like a local file system. I'm torrenting directly into Google Drive, and it never touches my local system other than the cache. There's a REST API for management if you don't want to use the web GUI. Command line is obviously totally usable as well. One thing I would keep an eye on in FreeNAS is when you're making changes in the command line, they might not be saved unless they're also done in the web GUI. So VMware Snapshots virtualization. So when you're using FreeNAS to store your VMs from ESXi over iSCSI, ESXi does not allow you to take snapshots from the VMware side, so you can definitely do that on the FreeNAS side. There's a whole other GUI page for that. It's really easy to do. So one thing I'm doing at home, and I thought this was pretty cool, is I am actually hosting all my VMs for ESXi on the same host. So what I mean by that is I have my FreeNAS VM that auto starts up. It's saved on a little old WD mirrored like 80 gig drive. And all my other VMs are actually running over iSCSI to that VM. So I start up the VM. I have this little script that rescans the iSCSI interfaces on the ESXi machine. And then it will boot up all my other VMs. And it's completely transparent on the same exact physical hardware. And I'm running pfSense there too. And what that allows me to do is I have a virtual interface attached to the pfSense, and I can route all my other VMs through it, so they've all got their own little firewall. All right, jails, everyone's favorite. So quick history about jails. It was first committed in 1999 with the release of 4.0. So jails are a system of OS level virtualization. So the interaction between jails, other jails, and the host are restricted, although you can open that up through various methods like we saw in Michael Lucas's talk previously. So on FreeNAS, the primary purpose of jails are to separate services from the host, and that means you can run anything you want as long as it runs on FreeBSD. And you can also take advantage of the ZFS storage, which is already on the machine. So in FreeNAS, they use IOCage instead of the jail management utility. We heard a little bit about IOCage previously, and I'll talk about that as well. So the IOCage jail manager, it's written in Python. It used to be written in just shell scripts. There is a fork of that from that time called IOCell. It's very usable as well. IOCage is sort of the star player right now, and to be honest, it's pretty well deserved. So it's significantly easier to use, both because it's in the web UI in FreeNAS and because the syntax is a lot nicer than jail. So it's highly integrated with ZFS, and thus it requires ZFS. So IOCage supports plugins. And plugins are have been referred to as a Docker killer. And I think they're certainly a competitor to Docker, but we need to differentiate between what the user experience is and what the actual underlying hardware is. Or sorry, the underlying tech is. And so let's talk about the plugins here. So here's a big list. These are all click install, wait a few seconds. It'll download whatever it is. Your jail, done, all set up, no configuring, no CLI necessary. So here's a quick list of some of the popular ones: Plex, Transmission, QBitTorrent, Deluge, Couch Potatoes. All the ones up there are sort of media related. Some other ones, GitLab if you're doing development work, ClamAV if you want antivirus of some sort, Redmine for bug reports, MineOS for hosting Minecraft servers. All right, so let's look at what an IOCage plugin actually is. So it can be broken down into 5 components: a JSON artifact. And so what that consists of is the name of the jail, various options, VNet on, allow raw sockets, whatever it may be, the packages to be installed, and once that's done, it'll create the jail. And UI.json is something that's mostly applicable to FreeNAS because it pops up a little window in the web GUI that has maybe the admin address or whatever information you want to display in there. But it'll also pop up in the command line if you're using it on vanilla FreeBSD or nested in a jail or something. It's got a settings.json file, which you can specify additional user-created stuff that will be taken in by post install. So the post install is a little shell script that after the jail is created and has network connectivity, and that's been tested successfully, it'll run the post install shell script, which does various things, enables a service, echoes a line to a config file, specifies whatever options was specified in settings.json. And the last, we have overlay, which is simply a set of files or directories that you want pushed into the jail when it's created. So the artifact repos are hosted with Git. You could probably host them elsewhere, although I don't think that's supported at the moment. So the JSON file contents, like I just talked about, there's a list of them there. You can specify the package site as well, and what that allows you to do is use your own, or you can use TrueOS's, or you can use, I believe, there's a few other public ones, or just the vanilla one from FreeBSD, like if you want to use latest or something instead of quarterly. All right, Beehive, everyone's favorite hypervisor on BSD. So Beehive, the BSD hypervisor began in FreeBSD 8.1 and was added to base in 10.0. It was added to FreeNAS in 11.1. So in FreeBSD, it's a loadable kernel module, although in FreeNAS, it is enabled by default. It's one of the only ways to manage Beehive with a web GUI at the moment, although there are some projects coming out, hopefully soon, that will have some other options if you want to just install it on vanilla FreeBSD. So it supports various operating systems, FreeBSD and OpenBSD, some Linux flavors, Windows, maybe one-on-one Windows Server for your Active Directory or OpenBSD or something. So you do require hardware with extended page tables. That is one sort of big, I don't want to say requirement, but some little tiny NAS chips, maybe little Atom might not support that. So one thing I will warn is doing everything with FreeNAS. If you're just doing storage, great, but don't try to load it up with 15 VMs and 18 jails and then complain when it's slow. So on FreeNAS, right from the web GUI, you can connect to a VM both with the use of a virtual serial port or a VNC connection. So there used to be a Rancher OS VM which added support for Docker. That's been since deprecated. You can still install it if you want to. You can still install Ubuntu and configure Docker manually if you'd wish to as well. So reporting and monitoring, just like pfSense, FreeNAS does have a great little web GUI with various pretty graphs and such. It'll also generate alerts that'll pop up in the web UI when you log in. You can also have those emailed to you or sent to some other monitoring service. And certain types of alerts have certain levels of severity, so maybe you don't care if there's a new update available, you don't want to be alerted for that, but you do care if your pool went to degraded state or something. So one thing I will note here is if you're doing smart testing, the alerts for that are sent separately from the typical alerting structure on FreeNAS. So you can collect metrics via Graphite and pass them into Grafana, and maybe you want to host Grafana in the jail, you can absolutely do that. So there's also Netdata. Netdata is a monitoring GUI as well that's completely separate. You can also pass in metrics from other services. You just enable the service on FreeNAS. It's a separate web GUI. One thing I will mention here as well is that services and jails are not seen by the host unless there is some agent to monitor them. And certainly you can see the physical services, but you might not see the actual status of them if it's something a bit different. All right, so how it all fits together. So these two projects are great. They're FreeBSD based. They've introduced a lot of people into FreeBSD, including myself. And I think since they're both FreeBSD, they go together really well. So maybe you want to access your FreeNAS on the road, and maybe don't open up SSH or something to the web or Samba or something. Put it behind a VPN. Put that server on your FreeNAS. You can remote in. You're exactly like you were on your LAN. Do access control. So if you want various other users to access the pfSense web GUI for administration, you can base that user off of something like LDAP or AD or something that's hosted on the FreeNAS in some way. You can host monitoring services. Put up a Grafana dashboard. Host that in a jail. Use that to monitor your FreeNAS. Use that to monitor your Windows server. Use that to monitor your pfSense. And there's various guides online to do that, various templates as well if you don't really feel like going through the it is a pain to set up the prettiest dashboard ever, I will admit. So maybe you're serving quite a bit of data from your FreeNAS and you want to make sure nothing's fishy going on. So put on Snorter Suricata and sniff through that traffic and make sure nothing nefarious is going on. You can use pfSense to load balance various services if you're hosting those in your FreeNAS. Let's Encrypt is sort of a pain to manage. Acme is the least painful option. You can install that on pfSense and use that to monitor, to administer not only your certificates on pfSense, but also ones on elsewhere in your network, like in your pfSense, or sorry, your FreeNAS. You can use Squid to cache content. Squid is very useful for a lot of things. All right, so importance of these projects. pfSense and FreeNAS have both fostered quite large communities that a lot of very awesome users who help people. They talk about things. They contribute if they can, and a lot of people have gone from FreeNAS and pfSense into FreeBSD. It's an introduction to novice user because maybe someone who's never seen a command line doesn't really want to hop into the terminal and start going. You absolutely can if you want to. But for a lot of people, the web GUI is a really nice way to start. You've got the visual feedback. You've got the instant gratification. Popularity. Both these have put ZFS into the hands of a lot of people. pfSense has ZFS en route now. I believe that's by default. I don't think they even support UFS en route. Correct me if I'm wrong. They use a lot of other open source technologies that you can install either via plugin or package manager or however you want to do it. They've introduced that to a lot of other people. White box hardware, because sometimes you don't want to buy that big box server from insert giant proprietary vendor here for a lot of money and a lot of support contracts. Both these will run on just about any old hardware that's not from the 90s. So put it on there with, burn it to a USB stick, install, you're off to the races, you're good to go. It's, like I said, it's put OpenZFS in the hands of a lot of people, more than just about anything else. All right, so thank you both to everyone for coming by to see the talk, and to VeriSign for the great conference and all the great food that I'm sure we all enjoyed. All right, cool. Well, thank you very much. Have a great day.